Traditional therapies for substance use disorder, like buprenorphine or naltrexone, are built on a specific logic. They target a single receptor system to either block a drug's effect or mitigate physical withdrawal. However, addiction is a chronic systemic dysregulation. It is rarely confined to a single receptor, instead spanning multiple circuits across the brain. This network, the mesocorticolimbic circuit, governs the underlying mechanics of reward, stress, and executive function. In an addicted state, we see pathological hyperactivity across four key nodes: the VTA, the nucleus accumbens, the amygdala, and the hippocampus. Cannabidiol, or CBD, functions as a promiscuous neuromodulator, engaging these various regions through pathways distinct from those typically associated with cannabis. It operates through polypharmacology. A single dose of CBD simultaneously interacts with multiple neurotransmitter systems, including the cannabinoid, serotonergic, and glutamatergic networks. This broad-spectrum activity moves addiction treatment away from isolating a single receptor, focusing instead on the holistic repair of the brain's signaling networks. The primary mechanism of drug intoxication is the forced phasic release of dopamine. This surge travels from the ventral tegmental area to the nucleus accumbens, providing the powerful reinforcement that drives continued use. CBD does not alter baseline dopamine levels or VTA firing on its own, which explains why the compound itself has no inherent abuse liability. When pushed into a hyperdopaminergic state by drugs, CBD intervenes, smoothing the curve toward a normal baseline without suppressing healthy dopamine function. This normalization occurs at the CB1 receptor. CBD binds to a secondary site, shifting its shape to partially reject incoming drug molecules. Chronic administration also induces longer-term shifts. It downregulates the dopamine-synthesizing enzyme tyrosine hydroxylase in the VTA and reduces mu-opioid receptor expression in the nucleus accumbens. By applying these brakes to reward amplification, CBD neutralizes the high of addictive substances without blunting the capacity for natural pleasure. As intoxication fades and withdrawal begins, the neural focus shifts to the stress circuitry of the extended amygdala. During prolonged abstinence, this region becomes hyperreactive. Surges of stress hormones like cortisol and CRF frequently trigger cravings that lead back to drug use. CBD intercepts this cycle by acting as an agonist at the 5-HT1A serotonin receptor, sending an inhibitory signal that calms the amygdala's output. Preclinical data confirms the necessity of this pathway. When the 5-HT1A receptor is pharmacologically blocked, CBD's ability to reduce drug-seeking behavior disappears. A landmark 2019 human clinical trial tested these findings on abstinent individuals with heroin use disorder. Following a single course of CBD, subjects showed a significant suppression of both cortisol levels and cue-elicited craving. By day 7, plasma CBD levels had returned to 0, yet the reductions in cortisol and craving remained fully intact. This persistent effect, occurring in the absence of the compound, suggests that CBD facilitates a lasting recalibration of the brain's stress response. Finally, we must address the hippocampus and prefrontal cortex. These regions house the rigid, pathological memories that lock addictive behavior in place. Addiction dysregulates glutamatergic signaling here, creating inescapable triggers when a person encounters drug-related environments. CBD acts as a state-dependent stabilizer for glutamate. It addresses both depleted receptor levels from heroin withdrawal and overactive levels from cocaine exposure. In both scenarios, CBD pushes the system back toward a balanced baseline, upregulating or downregulating receptors to counter the impact. This synaptic stabilization is supported by deep intracellular cascades. CBD increases the levels of brain-derived neurotropic factor and phosphorylates the Krebs transcription factor. These molecular signals stimulate structural neurogenesis, prompting the birth of new neurons and the formation of fresh synaptic connections in the hippocampus. This structural growth is a requirement for recovery. When neurogenesis is chemically blocked in studies, CBD no longer reduces cocaine-seeking behavior. By physically rewiring the circuits that encode drug memories, CBD accelerates the extinction of addictive associations. The addiction cycle is a 3-part loop: intoxication, withdrawal, and the anticipation of the next dose. CBD blunts the dopamine-driven high of intoxication by negatively modulating the CB1 receptor.
It eases the anxiogenic crash of withdrawal by activating 5-HT1A serotonin receptors, and it disrupts the anticipation of cues by stabilizing glutamate signaling and fostering new neural growth. Crucially, this intervention dismantles the cycle without introducing a new intoxicating substance or a different form of dependency. While single receptor medications provide a narrow roadblock for specific symptoms, CBD addresses the broader neurobiological imbalance. It represents a shift toward homeostatic neurobiological repair, recalculating the brain's internal signaling to restore a state